hold onto your hats because this journey is about to embark on a tour through the world of artificial intelligence and robotics that promises to be as groundbreaking as the discovery of a new continent. Have you ever heard of the OpenX Embodiment dataset and RTX models? If not, you are in for a treat. This is a mixture of knowledge and experience that can transform an ordinary robot into a super adaptable, mega-skilled machine. It might sound like something out of a science fiction movie, but rest assured, this is real. And it's happening right now. So are you ready to dive deep and explore this uncharted territory with us? Buckle up, it's going to be an epic journey. The journey begins by taking a step back to understand where the world of robotics is coming from. In the world of robotics, there has been a significant challenge for a long time. Robots like musicians who can play one song beautifully have been excellent in performing specific tasks but struggles when faced with new challenges. It's like teaching someone to play one song on the guitar. They might master it and play beautifully every time. However, when handed a new sheet of music, it might not be so smooth. This has been the story for robots. They excel in specific tasks, but life is not always about playing the same tune over and over. The real challenge is to enable them to adapt, learn, and not stick to the same old. This is where Google DeepMind, the brilliant minds at Google, entered the scene. When they noticed this limitation in robots, they didn't shy away from it. Instead, they saw it as a challenge. They pondered, how can we make robots more adaptable? And this is where it gets exciting. They decided to collaborate with a whopping 33 academic labs, which is nothing short of a monumental. Imagine all that brainpower coming together for one massive project. It's like when Avengers assemble, but in the world of robotics. The goal was clear, to create a robot that isn't just smart at one thing but can handle a broader range of tasks. It's a significant step towards having robots that are more human-like in their approach, capable of learning from different situations and being adaptable. Now, let's dive into the heart of the matter. The OpenX Embodiment dataset. Have you ever wondered where artificial intelligence gets its smarts from? Just as humans learn from books and experiences, AI and robots learn from data. The quality of this data significantly affects on how smart they can become. Google DeepMind, in collaboration with these labs, came up with something called OpenX Embodiment dataset. The name might sound fancy, but stick with us. It's like a massive library, but instead of books, it's filled with robotic experiences. This dataset includes data from 22 different types of robots, showcasing over 500 skills across 150,000 tasks. Yes, the audience read that right, 150,000 tasks. It's not just the sheer size of this data that's impressive, it's a diversity that makes it remarkable. The beauty of this dataset lies in the variety of the experiences it captures. It's not just about collecting vast amounts of data, it's about how to use it. So, having all this data is cool. But what do you do with it? It's like having a mountain of Lego bricks. You need a blueprint to build something epic. This is where the RTX model comes into play. Developed by the wizards at Google DeepMind, it's an amazing blend of learning from all those robotic experiences we mentioned earlier. Think of it as a super robot brain that feds all the knowledge from the OpenX dataset. But it's not just about cramming knowledge. The magic lies in the architecture. Have you ever heard of the transformer architectures in AI? It's a cutting-edge stuff that makes the RTX model incredibly adept to processing information and learning what's essential. It's like giving that robot brain a massive boost in its processing power and learning capabilities. Now, let's address the elephant in the room. The audience has this shiny new RTX model, but does it actually work? It's one thing to have a fancy model on paper, but it's a whole different ballgame when you see it in action. Remember the time the audience tried that new recipes that looked great in the cookbook, but the real test was in the taste. Similarly, when the RTX model was put to the test, it was like watching a rookie step up to the big leagues. And guess what? It didn't just participate, it knocked it out of the park. The RT1X model showed an impressive 50% success rate improvement across different robots. It's as if the RTX model was the secret source adding that extra flair to robotic tasks. But wait, there's more. The RT2X model took it even further by tripling the performance on real-world robotic skills. The sheer adaptability it demonstrates was nothing short of astonishing. Robots weren't just mimicking tasks, they were interpreting, adapting, and showcasing a finesse that was hard to imagine before. With such impressive capabilities demonstrated in the lab, it's only natural to wonder about the real-world implications. While the RTX model and the OpenX Embodiment dataset might sound super sci-fi and a bit geeky, they have real-world implications that are pretty wild when you think about it. Beyond making smarter robots, we're talking about enhancement in autonomous systems, innovations in smart homes, and breakthroughs in areas like healthcare technology. Imagine homes becoming smarter, with lights adjusting based on the mood, kitchen appliances responding to voice nuances, or even a robot chef whipping up pancakes or a gourmet meal. Factories could become more efficient with the robots that can switch tasks seamlessly, and healthcare tools could understand nuanced instructions and help its patients more effectively. But it's not just about making everyday life more convenient. These advancements can also play a crucial role in situations where human intervention is risky, such as disaster response. Robots that can understand complex instruction and adapt could be a game changer to rescue mission and disaster relief efforts. The big picture here is collaboration. Over 20 institutions are coming together, sharing resources, bouncing ideas off each other, and honestly trying to leap over the hurdles that have kind of been the bane of robotics. It's not just about the tech, it's about the humans behind them. It's about the researchers, experts, and even enthusiasts like the audience who are diving deep, exploring, and building on this mammoth idea. The idea is to have robots and tech that aren't just isolated in labs and factories, but are part of every stories, in homes, communities, and in ways that might not even have been dreamed of yet. This collaborative effort is like pouring rocket fuel on a bonfire. When brilliant minds come together, it's like different instruments coming together in an orchestra, creating a symphony that just works. So, what's the big picture with all this talk about robots and AI? It's about a shared vision. We've got over 20 institutions coming together, sharing resources, bouncing ideas off each other, and honestly trying to leap over the hurdles that have kind of been a bane of robotics. It's not just about the tech, it's about the human behind it. It's about the researchers, experts, and even enthusiasts like the audience who are diving deep, exploring, and building on this mammoth idea. The idea is to have robots and tech that aren't just isolated in labs and factories, but are part of everyday stories, in homes, communities, and in ways that might not even have been dreamed of yet. This collaborative effort is like pouring rocket fuel on a bonfire. When brilliant minds come together, it's like different instruments coming together in an orchestra, creating a symphony that just works. The future, especially in tech, is like a vast ocean of possibilities. When brilliant minds collaborate, it's like pouring rocket fuel on a bonfire, speeding up the progress in technology. It makes one wonder, when the walls are broken down and learning is shared, how fast can the tech world grow? Not in isolated bubbles, but as a global community, truly working together. This journey isn't just about flashy tech or robot upgrades, it's a hint at a vision where technology understands, learns, and adapts much like humans. The excitement here isn't just about the end product, it's about the journey, the shared vision, and the collective push towards a future that looks remarkably promising. So, what's next? The next big leap, the next innovation. The future holds incredible promises, and it's a future of general-purpose robotics, intuitive technology, in a world where robots are not just functional but also deeply integrated into daily lives. It's a future that is exciting, and the audience should be genuinely curious about what's next. The OpenX embodiment dataset and the RTX model represents a vision where technology understands, learns, and adapts like the humans. It's not just about the end product, it's about the shared vision and collective efforts towards a promising future. What's next? The future promises general-purpose robotics, intuitive technology, and deep integration into daily life. It's an exciting future, and we hope you're genuinely curious about what comes next. Thank you for watching, and we look forward to catching up in the next video.